So this problem is a conceptual problem to determine what a graph of a function looks like that is one-to-one and is not one-to-one. Okay, so first part, the graph of a function that is one-to-one. A function that is one-to-one, well, it's a function, so it must satisfy the vertical line test because it's a function, and it's one-to-one, so it must satisfy the horizontal line test. So pretty much anything that satisfies those two criteria will do. So this is a function. It satisfies the vertical line test. Also, it satisfies the horizontal line test. Every horizontal line that goes through that function intersects the graph at most once. All right, second part of the question. Draw the graph of a function that is not one-to-one. Okay, so I want it to be a function, so it still has to satisfy the vertical line test, but it must not satisfy the horizontal line test. So here's an example of something that is not one-to-one. It certainly satisfies the vertical line test. Every vertical line that intersects the graph intersects the graph at most once. However, here I have a horizontal line that intersects the graph twice. And so this is an example of a function that is not one-to-one. There are certainly other types of functions that satisfy these two properties. So the pictures I've drawn here are certainly not the only things that would work, but they work. And so this would be an appropriate answer. All right, now before I go, I want to say this is a wrong answer. So don't do this. So drawing something like this would be the wrong answer because this does not satisfy the vertical line test and therefore is not a function. So yeah, it doesn't satisfy the horizontal line test. So here you can see there are places where a horizontal line intersects twice, but this is not the graph of a function in the first place. So for a question like this, don't give me something that is not a function. Make sure that the graph is indeed a function, but it is a function that does not satisfy the horizontal line test.